Page 9 of differentiation rules. So from the reading or from the investigation, remember that there's a nice symmetry with the derivatives of the trig function sine and cosine. The derivative of sine is cosine, and the derivative of cosine is negative sine. And of course that only works perfectly when it is in radians. Okay, so when you're in degrees, then there's going to be a chain rule and something else multiplied there, so it gets messier. Which is one of the reasons why radians is cool for math. The derivative of tangent x. Consider that y equals tangent of x, which is sine divided by cosine. Remember that tangent is opposite over adjacent, sine is opposite over hypotenuse, and cosine is adjacent over hypotenuse. Well, if you divide opposite over hypotenuse by adjacent over hypotenuse, remember you need to multiply by the reciprocal when you divide by a fraction. So you end up with this, right? And the hypotenuse cancels out, and you end up with O over A, opposite over adjacent, which is tangent, right? We let u equals sine x and v equals cosine x and use the quotient rule to find the derivative of tangent x. Okay. So let's take the derivative of tangent. So since we're going to do quotient rule, I just wrote it there, u dash v minus uv dash divided by v squared. You can copy that off the formula sheet. And remember, in this particular case, u is the numerator, which is sine x, because the numerator of tangent is sine x, and v is cosine x, because that's the denominator. And u dash would be cosine x, like we said above, and v dash is equal to negative sine x, which we also wrote above. So now let's just substitute in everything. So in the denominator, v squared would be cosine squared x. And in the numerator, u dash would be cosine x, and v would be cosine x, and u would be sine x, and v dash would be negative sine x. So if we expanded this, it would be cosine squared x minus sine squared x, or plus sine squared x, right? Divided by cosine squared x. And cosine squared x plus sine squared x equals 1 because of Pythagorean's theorem. And so it would be 1 over cosine squared x, right? And if you wanted to simplify that a little bit, we know that there is a trig function, which is actually 1 over cosine x. It's called secant x. So we know that 1 over cosine squared x is also secant squared x. So sometimes in some textbooks you'll see that the derivative of tangent is secant squared x instead of 1 over cosine squared x, but it's the same thing. Okay? All right, moving up a little bit. Use the chain rule to find the derivatives for these functions. Okay, so if you have sine times something inside, the derivative of that would be cosine, and then you would just write, f of x exactly as is, right? So like, for example, this expression would be written exactly as is there. And then we would do the chain rule, and the chain rule would mean that we would just take the derivative of that yellow part there and multiply it times the first part. Same thing with cosine. So when we take the derivative of cosine, we would do negative sine x of f of x, so the inside part stays exact same. And then we multiply by the chain rule. We multiply by the derivative of the yellow part. Tangent x, remember the derivative of tangent x is 1 over cosine squared x. So we would put 1 over cosine squared f of x, and then we would multiply it times the inside of the cosine, which is f of x, and so that would just be f dash of x also. Okay. after you see the example 13 on page 380, you can move on and do some of these derivatives here, which involve chain rule and derivatives of trig functions. So remember, the derivative of sine of something is cosine of something times the derivative of that something. So if it's y equals sine of 2x, then the derivative is going to be cosine of 2x. And then we just multiply all this by the derivative of 2x, which is just 2. We could write that more neatly, 2 cosine 2x, then we don't need any parentheses. Let's look at C. Cosine 3x. So the derivative of cosine of something is negative sine of something. The something we just write as is. And then we multiply that times the chain rule of 3x, which would be 3. And of course, the derivative of sine x is just cosine x, right? So if I wanted to write that without parentheses, I could write it like this. Okay? All right. Now what about this next one? Y equals cosine of 3 minus 2x in parentheses. Remember, the derivative of cosine something is negative sine something. So we write negative sine, and then the something, which is the inside of the cosine 2x, this yellow part here, we just write it as is there. Then we need to multiply this whole thing by the derivative of the yellow part, which would be negative 2, right? Because the derivative of positive 3 is 0, right? Derivative of a constant is 0. The derivative of negative 2x is negative 2. So if we wanted to write it without parentheses, we could write 2 sine x because the negatives cancel out. 3 minus 2x. G. Y equals sine x over 2 minus 3 cosine x. Again, the derivative of sine something is cosine something. So we just write the inside part exactly as is, and then we multiply the whole thing times the derivative of the inside, which would be 1/2, right? And then derivative of minus 3 cosine x would be minus 3 negative sine x, because the derivative of cosine x is negative sine x, right? Now we can just like rewrite this so that we rewrite this so that so that we don't need any parentheses and a lot less negative signs, right? Okay, I. The derivative of 4 sine x, that's pretty easy. It's just 4 cosine x, right? The derivative of negative cosine 2x, okay, the derivative of cosine is negative sine, right? So the derivative of cosine something is negative sine something. And then we multiply that times the derivative of the inside, which is 2x, so it's 2. Let's rewrite that so that we don't need parentheses. So we'll put plus 2 sine 2x. Last one, derivative of sine x over x. So this could be done with quotient rule or with sine rule, or quotient rule or with product rule. I like product rule because it doesn't end up with a fraction at the end. So I'm going to rewrite sine x over x as x to the negative 1 times sine x. Okay? And then I'm going to rewrite let's say this is u and this is v. So first I'm just going to write u, and then I'm going to take the derivative of v. So the derivative of sine x is cosine x plus, and then I'm going to take the derivative of u, which would be negative 1x to the negative 2 multiplied times v without taking the derivative. So it would be that. Now let's see if I can rewrite this without extra negative signs and stuff. Something like that. Okay.